Hello everyone. I am starting up a series of Grainflow tutorials that I plan on releasing a new tutorial about once a week, maybe once every 2 weeks, depending on how busy I get. But I hope these are helpful in getting started with using my Grainflow package in Max MSP. If you're unfamiliar with my package, you can go to the package manager by pressing this button on the left and typing in Grainflow. Right now it's the featured package. So you can just click there and it'll say download here. And then you can download it. And then you should be ready to go with everything I'm doing in these tutorials. So for the first tutorial, I'm going to be focusing on some basics of the system. And we're going to be building a grain scrubber where we can click on this waveform object, and then we can have the grains follow our mouse in terms of time on the x-axis and amplitude on the y-axis. So just to demonstrate, we can create these patterns, and then I'm also going to show you how to loop them so you could layer some together and create some cool textures. Right. So I'm going to stop this, and let's get started on building this effect. So the first thing I'm going to do is I'm going to create a new patcher window. I'm going to save it. I'm just going to call this Grain Scrubber tutorial, and we'll be doing all of our stuff in this patch. So the first thing I'm going to create is a Grainflow object. And Grainflow needs a buffer name and a max number of grains. So for the buffer name, I'm just going to call this scrub grains, which we're going to create in a bit. And then for the maximum, I'm going to say 10. You could do less, you could do more. For this effect, really, I think all you need is 4. But we'll do 10. And there is our Grainflow object. Then I'm going to create a buffer named scrub grains. And you can give it a file name or drag a file onto it. I'm just going to do Anton by default, because I know everyone has that. Double click on the buffer and see we have loaded up Anton. All right, great. So now we have our buffer and our Grainflow object. We need to set up how we're going to actually hear this thing. So I'm going to make an mc.EasyDAC. So Grainflow uses multi-channel to keep all the grains separate until you want to mix them down. So we're going to be using a lot of MC objects. If you are not aware of the MC objects, you can create any MC object. So let's make this one mc.multiply tilde, and then you can go to extra help, and then you can get the MC wrapper features and message objects that can help you sort of understand that. So we have our output, and now we need a way of getting these 10 grains. So let's make a mc.plus. You can see that we have 10 channels coming out here, and we want 2, so we have it in stereo. So Grainflow has a built-in thing for this, and it's grainflow.util.stereopan. So I'm going to, and it needs an argument of the number of grains, just 10. So I'm going to connect this here, and it's just going to automatically pan the grains in a stereo field, which is pretty convenient. And then, because it's a good thing to have, I'm going to make an mc.live.gain. I'm going to make it horizontal so it fits a bit better, and connect it to my stereo pan right here. All right, so we have this basic setup, and now we need some things that are necessary for Grainflow to work. The first being the grain clock. The grain clock is a phaser that the grains are scheduled on. So we're going to make a phaser object, and the size and spacing of the grains is determined on the frequency of that phaser. So if I make it 2, we're going to get each individual grain is going to appear 2 times a second. So when we have 10, that's going to be 20 grains a second. So if I connect this to this first outlet that says sync phaser signal, we will be able to start getting grains. And the other thing is we need a point to sample from, which is in this second inlet, which for now I'm just going to use a noise. So it's going to randomly pick points for right now. And so we can see what's going on. I'm going to make a Grainflow.waveform object with the buffer name scrub grains. So we can see we have Anton right here. I'm going to connect my data outlet, which is the second outlet, and this will basically tell this object how to draw things so you can see what's happening. So in order to start Grainflow, we need to give it a 1 message to tell it to turn on. And here we go. So you can see we have all these grains that are sort of moving around in our Grainflow object. I feel like I've messed something up, and that's because you need this data output to go into the stereo thing. My bad. Yeah, I'm just going to go over what we've done so far, and that is we have this phaser that is controlling the grain scheduling, and this gives us 20 grains a second because each grain is going to happen 2 times a second, and we have 10 grains. And then we're sampling it randomly, the position, with this noise object, and we're going to replace this with something we can control by clicking here at some point. So then with that information, Grainflow is generating these grains, and then we're panning them with this util stereo pan object, which is just putting them in a stereo field so we can actually hear them, because we don't have 10 speakers to audition them individually. And then we're listening to the output. All right. So let's talk about making the scrubbing effect. So this Grainflow.waveform object, the last outlet, outputs some information about our mouse when we're over it. So if we just hover our mouse, it says idle. If we click it, it says clicking. And when we leave, it stops unless you're clicking, and then it will wrap around, actually. So we need to get this information to do some things. So we're going to have it so when we click, it turns on Grainflow and sets our traversal point to the point on that we're clicking on. As you can see, it's from 0 to 1, which is convenient because the inlet here expects a value from 0 to 1. So I'm going to make an unjoin 3 and a route clicking. Helps when you spell things correctly. So I'm going to route all the clicking messages because we don't want the idle ones. And then I'm unjoining all the elements. So I'm just going to put some number boxes here for now so we can see what in the world is happening. I'm going to put a toggle on this last one because it's our click. So you can see I'm clicking and I can move around, and we're getting the X on this first number and the Y on the second. I unclick, and that clicking toggle, which is the last one, it turns off. So we can move our clicking toggle to connect to this toggle that's turning Grainflow on and off. I can delete this noise, and I can make a we'll make a line tilde object so we get a little bit of smoothing. We'll do it every 5 milliseconds. So I'm going to create a message, which is a $1. So the thing we send to it will replace that, and then 5. So it'll take 5 milliseconds to interpolate. And we're going to use our X value there. I'm going to connect that to our traversal as signal which says where we're sampling the grain. So let's try clicking. You can see it follows our mouse. And when I stop clicking, it stops. So great. It's doing exactly what we want so far. And we're also going to use the y-axis to control the amplitude using this amp message. So I'm going to connect this to the amp message, connect that to the first inlet of Grainflow. And now when we click, we can also control the amplitude. So awesome, we can now click and drag and create these sort of shapes with our mouse, which is a very intuitive way to work with granulation. But before we go into adding the looping, I want to add a couple more features to this Grainflow object so we have a bit more control. First, I want to have a thing where I set the grain size but in milliseconds instead of in hertz, because it's a little bit more intuitive, I think, to do that. So right here is going to be the value in hertz. We'll say grain period. And hertz is right here. So I'll show you the grain frequency. And then I'm going to make another float box, which is going to be our grain period or grain time, because they're the same in this case. Grain time in milliseconds. We're just going to have to do a little tiny bit of math. First, we need to convert milliseconds to seconds, which we divide by 1,000. And then we need to invert seconds to get frequency, which we can do by dividing 1 by a number. We'll invert it. So we need to do exclamation point divide 1 point. And for some reason, it connected to itself. Oh, I had 2 objects. Connect that here, and then that will convert milliseconds to hertz. So let's say I want 250 milliseconds, which would be like a 16th note in 120 beats per minute. You can see it sets that to 4. Actually, that'd be very 60 beats per minute, 120. Click. You can see your grains are much shorter. They happen more frequently. So I can make this something like 10, and we'll go super speedy. We can get some cool effects using that frequency, because the grain frequency, we're actually hearing the grain onsets along with the little bits of grains to create a new sound. That's what happens if you go above about 30 hertz here. So we have 50. We can still hear the grains as individual, like, beings. Unless we just sit here and we create a period, which is going to bring us to our next thing we're going to add, which is a delay random. And we just want to be $1 there, not all that other stuff I typed. And we can just connect this to Grainflow, and this will allow us to set our delay time random in milliseconds. So I'm going to say 50 milliseconds. Now if I click and hold, we get more of a sustained effect than the period we created before. And the reason when we have no random, we get this like drone, is because it's repeating the exact same grain every time, which then we hear just as a cycle, as opposed to as individual grains. So the more randomness we add, we can get away from that and figure out where the just noticeable difference is. So it doesn't take much, even 1 millisecond will get rid of that effect. Yeah, see, we can sort of hear both at that point at 0.1. Yeah, you can sort of play around with that. That can be a fun thing to mess with. So I'm just gonna put a comment here. This is random delay in milliseconds. All right. So now we have the basics of this down. I want to add a thing that will allow us to loop the grains like I had before in the example I showed. So we're going to use a multi-track recorder to do this. And this is not part of Grainflow, this is just part of Max. And this will allow us to record and play back event data in Max. And we're going to have two tracks, one for our x-axis and one for our y-axis. I'm going to actually bring all of this up a bit so we have a little space to work with our MTR object here. So this first inlet is a control inlet, so we're not going to put anything into that, but we are going to use the second two inlets. So our x value goes into track 1, our y value goes into track 2. And the same with the outlets. So we're just going to connect these to where they would connect otherwise. It doesn't pass through recording when you are recording, so it's necessary to send both, which is a little messy, but it's just how MTR works. So to record something, I'm going to have to check this real quick to make sure I don't mess up. We send the record message. And to play it back, we send a play message. And then to stop playback, we send stop. And if we want to get rid of everything we've recorded, we send clear. And we send all these to the first inlet if we want to do it to every track, which we do want to do, generally speaking. So instead of having our mouse click turn on and off Grainflow, we're going to have it set the recording. So I'm going to make a select object, 0 and 1. So if it sends a 0, so the mouse is not clicked, it will bang out of this first one. If it is clicked in a 1, it will bang out of the second outlet. So I'm going to connect this here, this up, and if we're clicking, we want it to clear. We want to stop actually first. We want to stop, then we want to clear, and then we want it to record. So I'll go here. And if we unclick, we want the recording to stop, and then we want it to play. So we'll connect these to our MTR. There. Now when I click, okay, so what's happening is that we're actually spamming messages through here. So we need a change object, which basically is going to say once it receives a 1 and it receives another 1, it filters it out and doesn't send it through. And if it sends a 0, it'll do the same thing, but it's only going to send the value if it's different than before. So now we'll turn this back on. You can see it loops once every time, and that's just because we haven't set the attribute to loop. So I'm going to do after MTR loop 1, which tells it to just continuously loop when it plays. So now I can draw a shape. And it does play. And you can put any sound, of course, in there just by dragging something onto the buffer. We'll just open some samples. So, for instance, these oboe wind sounds, I'm just going to drag into here. Oh, and if you want the buffer display to update, you send it a bang. Can we do that? You could also alternatively connect this outlet that bangs when it loads a new file. So I can make different shapes, and they will loop every time. Then, of course, you can do anything that you can do with MTR with this message, with the messages it takes as well, like change playback rate, etc. But we won't cover that in this tutorial. So I hope this was helpful in getting started, and I'll see you all next week.